overriding philosophy at Ford Motor Company is to design and produce products that are the benchmark of value in contemporary driver-oriented cars. Products that ride and handle well, are safe and attractive, all incorporating the highest standards of quality. To accomplish such an important goal, we must be at the leading edge of today's technology, drawing upon our vast resources around the globe. Our involvement in the sophisticated fields of aerospace, electronics, and motorsports competition enables us to gain the knowledge and skill necessary to become an industry leader in the quality and integrity of our technologically advanced products. Today, you'll be meeting experts in the automotive field, people who you've heard about excelling in their own profession, like road racer Bob Bondurant, writer, race commentator Chris Economaki, and Ford Division Advertising Manager Edsel Ford II. All of our nearly 400,000 employees working throughout the world of Ford are committed to vehicles of functional integrity. They strive for cars built with character and pride, cars that incorporate safe and excellent performance that will be respected and desired by people who appreciate fine automobiles. And now, welcome to the world of Ford. As technology races into the future, it's important that our designs keep pace. Of course, they first attract attention by their exterior appeal, but as you'll see, there's another world of design underneath the skin.
Computerized development and testing programs produce Tempo's new $225 million HSC engine. High swirl engine technology yields better overall performance. Swirling the fuel mixture through the chamber produces leaner burn and higher torque with lower RPMs, resulting in fuel economy, plenty of power, and cleaner exhaust. Today's advanced engines are monitored by a sophisticated onboard computer, EEC4. This electronic marvel processes more than 1 million commands per second, an achievement that would take 11 years to accomplish with a hand calculator. This advanced computer delivers consistent engine performance, no matter what the driving conditions may be. City, highway, cold startup, or hard acceleration.
EEC4 is also faster and more accurate than other electronic systems. And it all starts with this tiny microchip. It is capable of processing a staggering volume of command instructions, thousands per second. Based on data sent from various engine sensors, the processor can monitor and control a mix of 41 different events, all occurring within 3/millionths of a second of each other. By measuring functions like throttle position, engine and ambient temperature, manifold vacuum, and the amount of oxygen in the exhaust, the control module can tell how the engine is running, whether it's pulling up a hill under load, even whether the air conditioner is on or not. Within microseconds, the microprocessor calculates optimum efficiency and performance and sends appropriate signals back to the fuel injectors, the ignition module, and other systems to adjust the fuel-air mixture and timing advance, all within 1/3 of a degree at 6,000 RPMs. If the driver presses harder on the accelerator to pass, if the temperature falls in a snowstorm or rises in the desert, if a gain in altitude enriches the mixture, the computer automatically and instantly makes the appropriate adjustment. The system can compensate for gradual wear of certain engine components and constantly monitors its own performance through self-tests. In the event of an engine problem, the computer can even tell technicians where it hurts. In short, EEC4 represents one of the most important technological advances ever seen in the industry.
We're using our technological experience and resources to improve the manufacturing process. We've taken advances made at our Robotics Application Center and applied them to factory operations. With more than 1,100 robots worldwide, we're already seeing tremendous improvements in product quality. Innovations like laser paint systems place Ford at the leading edge in automated systems applications. But our most precious technological asset lies in the inquisitive minds and innovative approaches of our people. It is they who bring technology to real-world applications and maintain a constant commitment to our philosophy, to engineer, to design, to manufacture, test, and assemble the finest quality cars and trucks in the world.
At Ford, cars have always been designed to have shapes that are pleasing to the eye. This is a direct result of a consumer-oriented philosophy, a philosophy which emphasizes the importance of creating tasteful vehicles that integrate the driver to his environment. It's this inner appreciation of creating a harmony between man and machine that makes Ford's design philosophy distinctive.
There exists in nature an inherent harmony, a balance of elements creating contours, composing contrasts, rich in variety, each unique, distinctive. There exists in man an inherent appreciation for nature, for beauty, for those objects which balance tasteful design and functional craftsmanship. Rarely does man create an object equal in beauty to those shaped by the wind. The process begins with a concept in the mind of a designer. Working within objectives created by years of extensive consumer research and dimensions defined by product planners, the designer constantly balances an eye for and a love of form with an awareness of function and feasibility. He must understand the science of ergonomics and the value of aesthetics. He must differentiate between design and decoration. Working within these constraints, the designer creates a concept that is at once pleasing to the eye, to the senses, to the performance demands of the driver. From initial sketches, the task and the process accelerate. The concept begins to take on form, dimension, complexity. An adjustable seating butt serves as a form of sculptor's armature, which allows the designer to think from the driver's point of view. Clay model workers sculpt and refine the lines as the car slowly moves from drafting board to reality. A special skin is applied. The car assumes its windswept shape and stance. It is then scanned, precisely measured by lasers. translated to a computer printout that product engineers can evaluate, then converted into computer models that test structure, performance characteristics, stress, durability, and reliability, long before the first actual working parts are manufactured. The concept has evolved from clay to computer model to this fiberglass model. It's now ready for yet another test to see if consumers find it appealing. Their suggestions are considered and the concept is refined before a commitment is made to build the first prototype.
Still, aesthetic appeal has little value if it's unable to function in the real world. Our engineers pay close attention to improving a vehicle's functional qualities, giving the driver the benefit of our experience. That experience shows itself when form is engineered according to the laws of aerodynamics to improve efficiency. These are physical qualities that a driver can appreciate, such as improved fuel economy, reduced wind noise, and the secure feel of improved road handling and stability.
Most people probably associate aerodynamics with fuel economy, but aerodynamics can also have an important influence on handling performance as well. This has been one of the most important trends among competition vehicles, and we've been able to work a lot of those theories into our production cars. In particular, the so-called ground effects, which racers use, are low front air dams and shrouds to prevent air from flowing underneath. This creates a partial vacuum that sucks the car down for better contact between the tires and the road. At the same time, an adjustable rear spoiler acts like an inverted aircraft wing in the back to push down on the driving wheels for better traction. Both of these concepts have influenced current Ford models.
The Thunderbird Turbo Coupe, for example, features an integral front air dam built right into the front fascia, which minimizes front end lift, particularly at high speed. In back, the high rear deck acts as a built-in spoiler, which in addition to providing more trunk space, adds to the downforce and increases traction. The Mustang SVO, a car that takes things one step further. It incorporates a functional wing spoiler that comes straight from the racetrack. Once, designers tried to make cars with fins that looked like airplanes. Now they're building cars that actually perform like them. In fact, with Thunderbird and Mustang SVO, Ford even went as far as to borrow materials, adhesives, and construction techniques from the aircraft industry itself. There's a definite lack of ornamental chrome, for example, that could interfere with airflow. Notice the rounded appearance of the nose and sides, the concealed wipers that cut down on turbulence, the doors which wrap over into the roof, and of course, the raised rear deck. All of these are becoming Ford trademarks and all contribute to handling and performance.
Efficient inside as well as outside. Our priorities dictate that every Ford car is designed and built around the driver. It's an emphasis on practical application of human engineering. We call it the science of ergonomics.
Ergonomics. We all hear a lot about ergonomics today. What is it? I asked the same question a long time ago. Really what ergonomics is all the instruments, everything laid out right in front of you, controls, turn indicators. You don't have to take your hand off the steering wheel. You can turn the indicator up with your fingers. Lights, windshield wipers. As I look at the dash, I can see the turbo gauge, also the overboost, the tachometer, the speedometer, all the things you need. If you want to reach down, turn the radio on, you can do that. You can reach the air conditioner, heater. Also, it has instrumentation, electronic instrumentation, that tells you if the engine's hot, light comes on, or if the oil pressure is low, the red light comes on. But everything's right in front of you. It's very nice.
Good ergonomics also means you don't have a lot of distracting details around the interior. It means placing the driver into a command seating position with good visibility and a comfortable posture. These articulated sports seats, for example, are completely adjustable for thigh, lateral, and back support, and infinitely adjustable for lumbar support. A seat you sit in, not on, improves the way you ride. And the way you ride in Thunderbird improves the way you drive.
A period of testing that comes immediately after a car has been designed and developed is crucial to its acceptance in the real driving world. At Ford, this is an important and exacting procedure. Because of this commitment to safety, quality, and value, only Ford has retained 5-mile-per-hour bumpers on all of our vehicles, 4 times as strong as the government demands, resulting in reduced insurance costs for many of our cars. Most importantly, minor damage is minimized in low-speed accidents.
Ford technicians have been involved in every manned spaceflight since Gemini, and we've put that technology to work. We designed, built, and maintain NASA's sophisticated tracking and mission control centers. Ford knows what it takes to conduct a perfect launch at the Kennedy Space Center, at our plants, and at the Safety Research Center in Dearborn. We're concerned about passenger safety. So we use modern technology to conduct over 300 barrier crash tests every year. In fact, we are the only manufacturer, domestic or foreign, to install 5-mile-per-hour bumpers on all our cars and trucks, resulting in reduced insurance rates. And we conduct in-depth safety research on the passengers themselves, using a family of anthropomorphic mannequins whose lifelike structures and responses are tested and evaluated over and over again.
Most people associate the word performance with motorsports, and they're right. It's another way for us to gather important technical knowledge. But at Ford, we believe performance must be translated to the everyday driver in terms of acceleration and ride and handling.
Ford has always been part of American racing, ever since Henry built old 999, and its presence in our sport is now on the rise. It's all part of a plan to bring a new generation of American performing cars to the market. Hi everyone, I'm Chris Economaki, and racing is my business. And what we see here is more than a racetrack. It's a laboratory on wheels. Where else is a better place to try out space-age materials, new and improved suspension systems, engines that are turbocharged, that have fuel injection, and electronic ignition systems to get the most out of our gasoline. And then there's aerodynamics. What happens when air flows over, around, and under a car? This is where the lessons are learned on the racetrack. You can't learn them on the proving grounds. And then these lessons are taken by the engineers and adapted to the new design. Every Saturday and Sunday, somewhere in America, the Ford nameplate is on the track, getting the test put to its cars. And everything learned in racing is part and parcel of the new generation of Ford performing cars, made in America. The 1984 Fords with electronic fuel injection and turbochargers, electronic engine controls, gas-filled shock absorber struts, McPherson strut front suspension, parallel 4-bar rear suspension, positive rack and pinion steering. All of these things on the cars you can sell today were on the car that set the track record that still stands at Sears Point in California. So Ford's on and off-track involvement has resulted in cars that are truly new and different. And are you ready to demonstrate these differences to the driving public? The fact that the suspension is smoother, that it doesn't lean so much in the corners, that the disc brakes stop the car better, that the seats are adjustable and more comfortable, that the ergonomics are there for you. It's a great automobile, and you have to be able to sell it. Ford has brought a new driving experience to the American public. An entire family of American road cars in the classic tradition of European Grand Touring machinery. Cars that are just fun to drive. How many of you, 2 short years ago, would believe that Ford would have 5 turbocharged models in showrooms today? From the raceway to the highway, Ford's out front. In the broad sense, we don't ask much of today's automobile. We want it to accelerate, we want it to slow down, we want it to stop, and we want it to turn. But what a difference between Brand A and Brand Z. And let's go to Bob Bondurant to see what the Ford does in that area.
What I'm going to do right now is take you for the ultimate test drive. I don't expect you to take your customer out, obviously, and drive this fast. But I want you to see and know how well these cars really handle. As I accelerate with the fuel injection, you don't have stumbling like you do with carburetors sometimes. As you see here, we just smoothly accelerate. Works great. It's fun. I like a car that really works well. This turbo coupe really works well. The best thing you can do now is get the customer in the car, sit them behind the wheel, and drive on down the road. Then you want to make sure that he finds an area that he can accelerate onto the freeway, where he feels how strong the turbo is. You also want to remember to talk about how well the car does corner. Quiet corners, because it has heavier sway bars, eliminates the body roll, has heavier springs and shock absorbers, gas-filled shocks, last longer, gives better return to the suspension travel, so the car handles better. It's got rack and pinion steering, so I have much quicker steering with precise control. Again, nice and smooth. It has a nice leather-covered steering wheel. It gives me a better feel with that leather-covered steering wheel. Most people don't think about that. Also, it has very nice seats that hold you in place. It's comfortable, but when you go around the corner, you aren't sliding around the seat. You feel very nice. The thing you have to do with this car to really appreciate it is really get in behind the wheel and drive it. That's the only way you're going to really feel what the car does, and you're going to be absolutely amazed. We're going around here quite quickly, and we're doing it in a Ford, and it doesn't feel like the old Ford used to feel. This car feels more like a European car. It has handling stability as well as the comfort built into it, but you've really got to get behind the wheel and drive it so you can really feel what's going on. You'll love it, as I do. Best thing the salesman can do is get the customer behind the wheel so that he can feel what the car is doing, feel it through his hands, his feet as he accelerates. Your whole body becomes at one with that car. Let him really feel the excitement and the fun of driving the car. This is my Turbo Coupe, and I really like the way it handles. It's a lot of fun. And I know if you get your customer in the car and let him drive these cars, he'll love it, and he'll buy it.
As you've seen, Ford is working to remain at the forefront in the technology of motion, now and in the future. We're proud of our accomplishments in each of these areas, all of which contribute to our understanding of how to build better cars. We're most proud, however, of the people, the hundreds of thousands of them internationally who populate the world of Ford. After all, without our designers, engineers, technicians, and assembly people, there could be no Ford accomplishment. And without our dealer body, salespeople, and dedicated service personnel, there would be no Ford success.